My name is Walter, and this is my video project about a database topic for my database class. So I decided to go with the topic of mobile databases, a little bit about them, popular choices, and a little bit of background information. So I thought we'd start with the general definition of a mobile database. It's either a stationary database that can be connected to by a mobile computing device, like your smartphone, or a mobile network. Many applications require the ability to download information from information repository and operate on this information, um, even when out of range or disconnected. So mobile databases are not used solely for the revision of company contact and calendars, but used in a number of industries. So coming down here, here's a couple of products, commercially available mobile databases that are typically used. And with that, I want to roll into, according to this site, the 5 most popular databases for mobile, and that is your Berkeley DB. It shows you right here the type of data that's used in the database, the license. Couchbase Lite, LevelDB, SQLite, and UNQLite. Alright, let's start with Berkeley. Berkeley is a family of open source libraries that allow you to manage your data either in the traditional relational way or as key value pairs. Another feature of the Berkeley DB is that the SQL API it provides is fully compatible with that of SQLite. As a result, you can make your SQLite applications use Berkeley DB as the underlying storage engine without having to rewrite them. Okay, and these are just going to be like little brief overviews of the different databases that you can use, the most popular. Couchbase Lite is a more document-oriented database. It says that it's stored in JSON documents. Each document may have one or more attachments, which are essentially uninterpreted binary data that is stored and loaded separately from the document itself. So it says Couchbase Lite together with Couchbase Sync Gateway and Couchbase Server are the 3 components of the NoSQL JSON mobile database solution offered by Couchbase. One of the key features is built-in synchronization through the use of the Couchbase Sync Gateway between local databases and databases in the cloud. That relieves a developer from the burden of writing their own sync code, so that can save you a lot of time. And then LevelDB, it's an open source library written from Google. It implements key value store, where keys and values are byte arrays, and data is stored ordered by key. It supports atomic batch updates, forward and backward iteration over the contents of the store, snapshots, caching, data integrity, and automatic data compression. It's got good performance across a wide variety of workloads. There's a direct quote from most of its authors. Moving on to SQLite. SQLite is also an open source library. It's a C library for managing relational databases that can be stored both on disk and in memory. It supports dynamic typing, transactions, full text search, single writer, multiple reader access, efficient range queries, and shared caching. That's a popular one. That's used a lot. UNQLite, there are a lot of people that incorrectly believe that UNQLite is the NoSQL counterpart of SQLite, although the two products are completely independent. A little fact, UNQLite is an open source database that exposes both a key value and a document store interface. It supports both in-memory and on-disk databases, transactions, multiple concurrent readers, and so forth. Okay, and now moving on to this article that I found that tells you how to choose a database for your mobile apps, the best thing to look for. This might have been actually the site where I've seen it. So first it says you want to start with the right support for the right platforms. So you want to make sure like the database can be used on a specific phone. Like if you use certain brands or certain databases, it might only be accessible to Android users and not necessarily iOS. So that is definitely something to consider when you're using your own mobile database. Security. When using synchronized and decentralized storage, it is important to access, transmit, and store data securely. Um, to do this, you need to address authentication, data at rest, data in motion, and read and write access. Um, it's saying that authentication should be flexible and allow for the use of standard, public, and custom authentication providers. For data in motion, communication should be over a secure channel like SSL or TLS. And for data read and write access, the database should offer granular control over what data can be accessed and modified by users. You need flexibility. The flexibility would dictate whether you can articulate the model requirements for your apps in an efficient and appropriate way. It would also dictate whether you can efficiently evolve your model as your requirements change moving forward. Model flexibility is specifically important in mobile because today's mobile apps evolve at a very fast pace, constantly updating. I know on my phone I get updates every single day for almost the same apps, it feels like. Debugging and fixing pesky conflicts, fixing bugs in your databases. For example, Couchbase Mobile uses revision trees with the default resolution rule. This is the same approach taken by revision control systems such as Git, and much different than clock-based systems that take a most recent change wins approach. It says that they're problematic due to the issue around clock differences across devices. So it's something to look forward to. You want to sync at the right times. Sync with the right partitions. And I thought this was a pretty cool part of the article, and it says, should you build or should you buy? And I'm just going to go ahead and read it. It says, when looking to add sync to your apps, you will need to determine if you should build a solution or get it from a provider. Building sync correctly is notoriously difficult and expensive, as it must deal with all of the complexities of distributed computing. For most apps, you'll be better off leaving data synchronization to a specialized stack and focusing on your app features. The key is choosing a solution that is flexible. If you go down the build path, be ready to expend a significant portion of your time and resources on building sync and supporting everything listed above. This is a little bit of the things that I found for my topic. This is the first time I've ever touched anything with web development as a game development student, so I don't know much, but it's pretty interesting. I don't have a very good knowledge background of the topics or all of the stuff as I'm learning it just now, taking this class. So it's pretty interesting stuff. Not my cup of tea, but this is a little look into mobile databases. Again, my name is Walter, and thanks for listening.